Hello everyone, I'm Aurelia Calce and I will present the Computer Integrated Manufacturing project that's about the Fusion 360 modeling and implementation of DFA analysis on a robotic gripper. Let's start with the introduction. Industrial robots are being used more often to replace human labor in various tasks. This has led to a new need for more advanced handling equipment such as robot grippers. They are used in different fields and applications such as industrial warehouse, operations, military, and even surgery. There are different types of robot grippers that are used in various areas, including gel-type, vacuum, magnetic grippers. The gel-type mechanical gripper is the most commonly used one, which has fingers that move parallel. Depending on the jaw design, two or more gripping fingers apply the force internally and externally while grasping the object. Robotic grippers are important as they help robots to perform different tasks effectively. There is an increasing competition from industrial robots to perform different tasks eventually. Therefore, diversity of robot grippers is developing for being more flexible and multifunctional. By using multifunctional robot grippers, it is possible to grasp variety of objects and materials in the working environment. Robotic arm is desirable and versatile since it provides robotic system to avoid multiplicity of gripping tools. The applications of different robotic grippers in the industry. We have hydraulic grippers, which are ideal for heavy-duty tasks because they have greater gripping power than pneumatic grippers. However, they are more complex to handle because they require oil pump and reservoir, which makes them more maintenance intensive and unsuitable for many medical and clean room applications. Pneumatic grippers, on the other hand, use compressed air and pistons to operate their jaws. They are versatile, low cost, and have a large grip force range, fast response time, and can operate in tight spaces. However, they have limited force and position control and require compressed air in the function. Electric grippers, commonly used in the machine bending and picking place tasks, provide high speed or moderate gripping force, but not as much as gripping power as the first one. Electric grippers come in two-jaw and three-jaw configuration, with three-jaw grippers being preferred for handling round or cylindrical objects. When choosing pneumatic grippers, consider your specific needs. Designing the model. Designing the model of a robotic gripper involves carefully planning, selection of specific components, and attention to detail. During the selection stage, various elements as fingers, movement, jaw configuration are considered. Designing the model consists of designing each component and assemble it all together. The design was created by utilizing an array of techniques to craft each individual component. Once all the parts were completed, we proceeded to assemble them into the final design by carefully establishing the relationship between the component using position, joint, motion features. We were able to simulate the final product and ensure the successful function. Here we have the CNC machining process. CNC machining is an effective and precise method for manufacturing parts with high accuracy and consistency. Let's delve in the CNC machining of the base plate of a robotic arm, focusing on two essential operations, facing and 2D adaptive clearing. Facing is a fundamental operation in CNC machining that involves removing a thin layer of material from the surface of a workpiece to create a flat and smooth surface. In the case of the base plate, the objective is to remove 1 millimeter of material from its surface. Here we have the adaptive clearing. After facing the base plate to achieve a flat surface, the next operation involves the 2D adaptive clearing to remove the material from specific areas of the base plate according to a predefined shape or contour. Adaptive clearing is the versatile machine strategy that optimizes tool path and cutting parameters to efficiently remove material from maintaining stability and minimizing tool wear. To perform a 2D adaptive clearing, the CNC machine first generates a tool path based on the desired shape or contour. of the part, considering factors such as tool geometry, cutting forces, and material properties. The cutting tool, often a ball and mill or flat end mill with sustainable geometry, is then guided along to the tool path by CNC machine controller. We have used the flat end mill tool for this operation. Now we have generating the CNC program. After concluding the tool path, we use Fusion 360 application to generate the CNC program. We start by working in the manufacturer workspace and creating a setup. We continue by creating tool paths for each operation, which will help to precisely work on the silhouette of the model. All is left is to verify and simulate the toolpath and to export the G-code, which is created at the end of the process. Implementation of DFA. DFA, or also known as Design for Assembly, is a system that analyzes the assembly process to assess its ease of assembly. The results of DFA analysis are used to various industries. Additionally, here are the possibilities for future development of expert systems based on the DFA methodology. The DFA analysis considers several factors such as the minimum part criterion, which is based on the number of components that the design has, and by applying this method, we choose and separate which are the parts that are really required at the final assembly and which one we can like remove or combine with other parts, so we make new components. The DFA analysis consider other factors, which are shape classification. We have like rational, non-rational, and dimensions. It considers symmetry, handling difficulties, like is it flexible, fragile, etc. The insertion difficulties, like restricted view of mating location, difficulty in alignment or positioning during insertion, etc. The robotic arm gripper has been optimized for better movement, distribution, and easier assembly. This was achieved by removing surplus links from the upper base section and consolidating two lower links at the central axis. This optimization has streamlined the gripper's structure, resulting in smoother arm movement and reduced overall load. This enhances the gripper's operational efficiency and it eases the assembly.